Good afternoon, everyone. I am Siddharth Pathak, and I am working as an application engineer in geotech at MIDAS Research and Development Center, Mumbai. So, I welcome you all to this webinar on modeling of NATM tunnels using Tunnel Wizard in MIDAS GTS NX. We will be starting with some theoretical background of tunnels, the overall capabilities of GTS NX for modeling different kinds of problem, and then like different types of tunneling approaches and their modeling in GTS NX. And ultimately, I will be focusing on the demonstration of an NATM tunnel model using a tunnel wizard, which we have in GTS NX. So, in this session, these are the contents. I will be starting with a brief introduction to the MIDAS GTS NX software and its capabilities, and then with theoretical background about the tunnels and the various tunneling approaches and their modeling in the GTS NX, and some of the case studies of the couple of tunneling projects across the world, and then at last I will be dealing with the problem demonstration of a 3D tunneling employing the NATM approach. So to start with, so the MIDAS GTS NX is essentially a finite element based software where actually we can do both 2D as well as 3D modeling over a single platform, considering static as well as dynamic loading. Further, if we are interested in applications such as the slope stability, we have actually both FEM as well as the limit equilibrium method capabilities on a single platform to do the slope stability assessment for any kind of problem. So apart from that, there are different possibilities for analysis, starting from the static analysis and the dynamic analysis. So if I talk about specifically with like relating to the tunneling applications, so we may need to analyze the tunnel deformations and the support design. So for that, static analysis may be useful for sequential excavation simulation. We may require construction stage analysis for considering the groundwater inflow and the lining pressure. We may need to consider the seepage analysis, and then for the earthquake and blasting effects in tunnels, we may need to go for the dynamic analysis for analyzing the stability of tunnel portals and cut slopes. We will be requiring the slope stability analysis, and then at last, the consolidation analysis may also be useful if in case of the soft saturated clay. So tunneling in soft saturated clay, where excavation or groundwater drawdown may cause significant long-term settlement due to poor pressure dissipation. So apart from that, these types of analysis can also be useful for the other geotechnical applications related to the excavation, dams, mining operations, and foundation analysis and slope stability assessment, like the landslides assessment. So all those things. So in this way, actually, GTS NX provides overall solution for various kind of geotechnical applications like slope, foundation, consolidation, tunnels, mining, dams, seismic analysis, as well as excavation. So these are some of the projects worldwide where the GTS NX has been used, starting from the tunneling projects and excavation, piled out foundations, embankment consolidation and ground improvement, and the slope stability assessment, then the soil structure interaction, and finally the analysis for dams. So now I would be starting with the tunnels. So before we discuss like numerical modeling and specifically NATM tunneling, let's briefly understand what a tunnel is and how these tunnels are generally classified. So a tunnel is basically an underground opening excavated beneath the ground surface, and it is designed to remain stable with or without support systems while serving its purpose like transportation, hydraulics, utility, or mining purposes. So a tunnel actually can be classified in several ways. First, based on their purpose, we have traffic tunnels used for like roads, railways, and metros, and conveyance tunnels used for water supply, hydropower, sewerage, and utilities. And the second, based on the type of material through which they are excavated. So then tunnels may be constructed in hard rock, soft rock, soil, or beneath river beds and other challenging geological conditions. So the ground conditions often govern the excavation method and support requirements. So the third one is based on the alignment. So examples include straight tunnels, spiral tunnels, used to gain elevation, off-spur tunnels, and inclined or slope tunnels. Then finally, based on the cross-sectional shape, so common shapes may include circular tunnels, typically used for tunnel boring machine operations, horseshoe-shaped tunnels commonly used in NATM, elliptical tunnels, X-shaped tunnels, and other specialized geometry. So in this webinar, our primary focus will be on horseshoe-shaped NATM tunnels and their numerical modeling using the tunnel wizard. And during this presentation, if you are having like any queries, you can just put it in the chat box, and I will be responding to those after the presentation and the problem demonstration. So now we will move towards the various kinds of tunneling approaches. So once the tunnel alignment and geological conditions are known, the next step is to select an appropriate tunneling approach. And the choice of this tunneling approach depends on factors such as tunnel depth, ground conditions, groundwater, tunnel size, and project economics. So in this way, tunneling approaches can be classified into different categories like cut and cover tunneling, sequential excavation method, bored tunneling by tunnel boring machines, and tunneling through drilling and blasting. So the first method is commonly cut and cover tunneling is commonly used for shallow underground structures such as metro stations and underpasses. I will be talking about each of these tunneling approach in detail in the next few slides. So similarly, the sequential excavation method is in this approach, the tunnel is excavated in stages and support systems such as shotcrete rock bolts and lattice girders are installed progressively. And the third one is the tunneling through the tunnel boring machines. So these machines provide a mechanized and highly efficient solution for long tunnels, particularly in urban environments where surface disturbance must be minimized. And finally, the with conventional method of drilling and blasting for tunneling, which is predominantly used in rock masses. So excavation is carried out through repeated cycles of drilling, blasting, muck removal, and support installation. Uh, so now we will be like talking about each one of these tunneling approach in a bit detail. So starting from the cut and cover tunnels. So one of the most widely used tunneling methods, which is particularly suitable for the shallow underground structures. So as the name suggests, the tunnel is constructed by first excavating from the ground surface, then building the tunnel structure, and finally backfilling the excavation. Because construction starts from the surface, this method is generally economical and practical when sufficient working space is available. So these types of tunnels are most commonly used for metro stations, underpasses, pedestrian passages, utility corridors, and shallow transportation tunnels. So the main issue in these kind of tunnels, because they require a large open excavation. So in these kind of projects, large excavation is involved. So this method requires effective earth retention systems, and such as diaphragm walls, sheet piles, or secant piles, as well as proper groundwater flow control measures to maintain the excavation stability. So here, apart from tunneling, the significant issues involved are the stability of this excavation phase, and how this groundwater is going to affect the stability. So further, in cut and cover tunneling, actually there are two approaches like bottom up method and top down method. So as you can see, this figure is like a bottom up method where the excavation is completed first, followed by construction of the base slab, walls and roof. And then the other one is the top down, where the roof slab is constructed first, allowing restoration of surface traffic while excavation of the tunnel continues beneath. So this is the like a modeling approach in GTS NX, where we do the excavation and then model the different parts of the tunnels, like the base slab, walls, roof, and then assigning the suitable water table conditions and loading conditions. The next one is the sequential excavation method, or the new Austrian tunneling method. So, so actually, this tunneling method is based on the concept that the surrounding ground itself should be treated as a structural component of the support system. It means we are relying on the mobilization of inherent strength of the surrounding ground as well, apart from the other kinds of support system. So, unlike the traditional approaches that attempt to completely prevent ground movement, NATM allows a controlled amount of deformation. In this way, the construction process, as per this approach, is based on a sequential excavation. It means a short section of ground is excavated and the support is installed immediately after the excavation. So this cycle will be repeated under the entire excavation of tunnel is completed. And so the primary support systems here involves like shotcrete, rock bolts, steel ribs, etc. And So, like this method involves like flexible excavation sequence as per the like geological conditions. So we can excavate the face in different kinds of sequence, like the top heading, bench, invert, side drift, etc. And so that's why due to this flexibility, this approach is suitable in variable ground and rock conditions. And these are also widely used for metros, highway, railway, and hydropower tunnels. So here, as I said, there may be different sequence. So for the excavation of tunnel face. So as we can see here, like the bench cut, ring cut, and the CD cut method. And now, basically, these different excavation sequence depends on the tunnel size and ground conditions. And after actually the simulation of this kind of approach in the software, we generally look for these kind of results. So suppose this is the ground support interaction curve. Basically, this represents the concept of like ground support interaction. Before support installation, the ground begins to deform and unload. So after, as soon as the tunnel is excavated, there will be a stress release and there will be the increase in the displacements. So after how much stress release we can provide the support. So how much stress release we can allow in the tunnel without the provision of support. So that we can estimate from this kind of interaction. So from the software we can get, and some empirical charts are available. From there we can actually find this maximum radial displacement which can be allowed in the tunnel before the provision of the support system. And then actually so we will get to know how much in terms of percentage also, how much stress release we can allow. And then after that much stress release the supports can be provided. So basically here in this, the blue portion represents the elastic behavior where the surrounding ground has not yet yielded. As the excavation progresses and stress relief increases, the ground reaches its yield strength and enters the plastic range represented by the orange curve. So the NATM allows this controlled deformation on that ground so that this ground can also mobilize its strength apart from the support system. uh, Now, apart from that, whatever support system we provide here, we need to assess that those kind of support systems like are suitable or not. So, for example, if I talk about the lining, so if we want to check whether the lining provider is suitable or not, we assess that in terms of the support capacity plots, where these are based on some approaches reported in the literature, like the Carenza-Torres method and some other approaches as well. So here actually these factor of safety envelopes are created, and after the analysis, whatever the shear force or bending moments we are getting on the tunnel lining across all the points of the tunnel lining are so those are plotted in terms of these kind of graphs. So if those points are lying within a particular factor of safety envelope, that means the factor of safety is more than that value. So suppose these points are lying within an envelope of 1.2, means the factor of safety across these points in the tunnel lining is more than 1.2. For this, if it is lying between 1 to 1.2, it means the factor of safety across these 3 points along the tunnel lining will be between 1 to 1.2. So as per the requirement of our design, like factor of safety, we estimate that whether the proposed lining is sufficient or not, or we might have to redesign that. So now moving further in this section of the next approach means the bore tunneling by the tunnel boring machine. So basically this is another widely adopted method. So unlike the NATM approach, which relies on staged excavation and support installation, TBM is a fully mechanized process. So in this, excavation is carried out continuously using a rotating cutter head located at the front of the machine as shown in this figure. So as the machine advances, precast concrete segmental lining rings are installed immediately behind the TBM, allowing the excavation and support system installation to occur almost simultaneously. So one of the major advantage of this kind of tunneling approach is its ability to minimize the ground disturbance and the surface settlement, and this makes it particularly suitable for urban environments where tunnels pass beneath buildings, roads, railways, and other sensitive infrastructure. So these kind of TBM tunnels are commonly used for long transportation, metro systems, utility tunnels, and water conveyance projects. And depending on the ground condition, these are generally classified into like three types, like the earth pressure balance, slurry shield TBMs, and the hard rock TBMs based on the type of ground. So, however, if we want to like simulate this sequence in the software, so we need to consider all the kinds of forces or pressures involved in the TBM operation, like the drilling pressure or face pressure, which is applied at the excavation phase, and it prevents collapse of the tunnel face and balances the earth and groundwater pressure. So this is critical for controlling settlement and phase stability. The next one is the jack thrust, which is generated by hydraulic jacks pushing against the installed lining segments, and it propels the TBM forward and influences the stress transfer to the segmental linings. And other one is the shield external pressure, which is the contact pressure between the TBM shield and surrounding ground. And the last one is the segmental external pressure. This is the pressure acting on the installed segmental linings, and it includes the pressure from the soil surcharge and the groundwater effects. And these are the forces we need to consider in the during the modeling. And in this way, we can model the entire process of TBM tunneling. And in this, we may need to assess the results in terms of this resultant displacement or the other components of displacement. It generally helps us to assess the ground movements around the tunnel, identifying the settlement zones, and understand how the excavation affects the surrounding ground. And this one is the material status input, which gives us some insight about the redistribution around the tunnel. And we can identify the regions which remain in elastic zone or plastic zone, so accordingly. So and this is useful for evaluating tunnel stability and generally the extent of influence zone around the excavation. Apart from that, we can see the distribution of the shear force or bending moments over the lining, and we can see whether the lining provided is appropriate or not. So the last one is the drill and blast method. So which is a conventional tunneling method widely used in rock masses and involves operations like drilling, charging, blasting, mucking, and support installation. So basically, the explosives are installed at the face of the tunnel here. And so for simulating same thing in software, we need to do the same thing, just like applying some dynamic load due to explosives at the tunnel face. So these are generally also commonly used for transportation, hydropower, mining, and underground cavern projects. However, their advance rate is slower as compared to TBM, and they may also generate vibration, noise, and overbreak. So requires careful blast design and monitoring. So in GTS NX, we can actually create this kind of blast loading. So we can generate a blast load for the controlled blasting based on some different approaches given in the literature, like the National Highway Institute US 1991 and some other approaches. And based on that, based on some input parameters related to explosives and like installation, the explosive borehole diameter, and other some other variables as inputs, we can actually create this kind of blast load and apply it into the analysis. And then we can assess the influences zone after each stage of excavation through the blasting. So this is the another approach. So lastly, before going to the software interface, I will be just quickly discussing about some case studies all over the world using the software and the different tunneling approaches. So first one in this regard is this Chisholm Dawu tunnel in Indonesia. uh, and these are the some details. It's like basically twin tunnels, and the length of tunnel is 470 meter, and the NATM approach has been used with the pre-support system due to the weak rock mass conditions. So umbrella arch method using grouted steel pipes has been implemented, as you can see in this model images as well. And this is the actual this terrain and the twin tunnels, as you can see in the actual site. So the 3D finite element modeling has been performed using MIDAS GTS NX, and detailed simulation of excavation stages and support installation are have been performed, and the ground parameters, mean the properties of this surrounding rock mass, has been derived based on the pressure meter tests data, and then the settlements in the tunnel has been like estimated from the analysis, and they have been compared with the field monitoring data. So as we can see in this graph, so this is the results for the 3D analysis through MIDAS GTS NX, and these are the actual monitoring data. And kind of from these kind of results, we can see that the 3D modeling approach has been like giving a good match with the actual settlements from the field monitoring data. And the next one in the line is the Warsaw Metro Tunnel line in Poland. Here actually the tunnel boring machine like tunneling through TBM has been done, and beneath an existing road viaduct and operational railway lines. So during the design phase, it had to be decided that whether this ground needs some kind of improvement like grouting or not before the actually starting of the TBM tunneling, because the existing structures are there, like the viaduct and the railway tracks are there. So the tunneling process may affect the stability of these structures. So for that, actually, the model has been created in GTS NX, and considering the different forces involved, as I mentioned in the previous slides during the tunneling process, and a kind of target volume loss means of 0.6% has been assumed based on the like similar tunneling projects within this metro line construction. So based on that, 0.6% volume loss has been applied to the model, and the phase pressure of the TBM has been calibrated. And then the entire simulation with the existing structure has been performed to see the kind of displacement beneath this viaduct. And there are some approaches reported in the literature. They have also been utilized along with the 3D simulation in GTS NX, and 2D simulation results have also been provided here. So if we see the results in terms of the trough settlements, so we can see these are the orange dots are the like monitoring results. So during the construction, ultimately during as soon as the construction of like tunnel excavation through TBM is started, so the monitoring data with like each stage of excavation has been compared. So as we can see that these are the monitoring data with this orange dot, and this the green line is for the 3D FEM analysis, and the other one, this blue line, is for the 2D FE based analysis. And apart from that, these are the some methods like proposed by PEC. So as we can see, the 3D model results give a closer match with the actual field monitoring data. And apart from that, these are the settlements beneath the viaduct, means that existing structure. So as soon means like with each progression of the excavation using TBM. So the monitoring data, so the field monitoring data has been taken, and it has been matched with the predictions, 2D as well as the 3D predictions. So as we can see, the 2D model predictions actually significantly overestimating the settlements, while the 3D modeling predictions were more closer to the actual field monitoring data. So in this way, actually, we can assess whether the TBM tunneling will be safe or not with the existing structure present, so without significantly affecting the stability of the existing structure, and whether if we want any kind of ground improvement or not before the starting of the tunneling process. So before I move to the problem demonstration, just one recent update about this MIDAS GTS NX. So we have got another approval from a competent authority. So means like this is BMC, Mumbai Municipal Corporation, and this authority has approved like use of MIDAS GTS NX for foundation analysis and high-rise building projects as per clause G of this recent circular dated like 21st of July. So where like for geotechnical submissions and specifically here as per this circular for the foundation analysis, the results from the MIDAS GTS NX are applicable. So now I will be moving towards the last thing, which is the basically the problem demonstration of a 3D tunneling model employing the NATM approach. So in this actually I am going to use the tunnel wizard provided in the MIDAS GTS NX. So here I will be considering the modeling of twin tunnel using NATM approach, and this is the tunnel wizard where we need to actually input some values regarding the geometry as well as the support systems and the mesh sizes, and the entire 3D model is automatically created, and we just need to click on the analysis, and after the analysis we can do the post processing of results like the plotting of the support capacity plots and the tunnel deformations, the shear force bending moments over tunnel lining, the axial force mobilization along rock bolts, etc. So this is the general workflow of modeling in MIDAS GTS NX. So generally, we need to start with the geometric modeling, where either we can import the geometry created in any CAD-based software or create the geometry in GTS NX. And apart from that, we need to assign the material property and the type of elements which will be assigned during meshing, and ultimately the meshing of the entire domain, and apart from that the consideration of the loading and boundary condition as per our application, and then finally analyzing the problem and then post processing. So here if I use the tunnel wizard, so these steps which are highlighted in red like the geometric modeling, mesh, and load and boundary conditions and the analysis stages means the tunneling projects may be having different stages as per the excavation sequences and the installation of support system. So then the automatic creation of those construction stages. So we just need to provide the material properties and assign the type of elements, and then after the analysis the post processing of results. So apart from that, these four steps will be automatically like taken care by the tunnel wizard. So now I will be moving to the software interface. So I will close this presentation as of now, and I will directly move to the software interface. So this is the software, means the interface for MIDAS GTS NX. So for creating like a new model file, I just need to go to new. And as this is an integrated platform for both like 2D, 3D as well as the axisymmetric analysis. So initially actually we need to select what kind of modeling we are interested in. So as for this problem, we are going to do 3D modeling. So I will go with these options, and I can set the unit system as per my requirement, and I can give any project title. So this is not necessary. We can skip this also. We can just simply click on OK. And at any point of time, actually, if we want to change the unit system, so we can change it from here at the bottom. So according to our requirement, and all the entered values or the material properties will be automatically converted as per the our selection of the unit system. So uh, generally for modeling, the first step is the geometry creation. So generally we have the tools for both the 2D as well as the 3D geometry creation here, where we can assign a point, circle, rectangle, or we can just enter the coordinates and create any kind of geometry. And we can convert a 2D geometry into a 3D geometry as well using these extrude, revolve, loft, sweep commands. And we can perform other operations like the assembling the different uh, 3D parts, like joining them. So using these kind of Boolean operations and some other operations over the geometry. So we can use these options. So then if we do not want to create a geometry here, we can directly import the geometry at these kind of formats, cat file dxf dwg. So now, as I mentioned, that we do not need to create a geometry here for using the tunnel wizard. We can directly go to the tunnel modeling. So we have this tunnel modeling wizard here. So once I click on this tunnel wizard will open up, and it will ask me some some of the inputs, like the size of the geometry or type of the cross section, and regarding the support system and the tunnel excavation sequence and the meshing. So but before that, as I said, we need to assign the material properties. So we here two things we need to do from our end: assigning the material properties and the type of elements. So those things we will be doing first. I will go to mesh. So in mesh tab, actually, these are the two options of assigning the material properties, where we can choose like different kinds of material models for different types of soils or rocks. So suppose for this problem, I am considering the some surrounding rock properties, and using generalized Hook and Brown model. Accordingly, I can give some the parameters like elastic modulus, Poisson ratio, unit weight, and in porous tab, if the problem is also involving the water table, then these parameters are also crucial. Then in nonlinear tab, I need to give some strength related parameters. So from here, I can assign the intact rock mass parameter, geological strength index, disturbance factor, according to the rock type, and these constants will be automatically calculated. And here I need to give input of the uniaxial compressive strength, and if I'm considering any dilatancy angle, otherwise I can put it as 0. So if I want to, anytime if I want to get in any information regarding the inputs of a specific constitutive model, I can always go to the online manual. So I can just go to the this, and I can then search for the generalized Hook and Brown. And if I do not have the parameters with me, so I will get a general idea of the values according to the rock types and the disturbance factor according to the types of operations. And then I can accordingly decide an input here. So as of now, I will be creating the rock properties first. So if actually there are two further ways of creating the proper assigning the properties. We have the import option and the import from Excel. So we can actually directly import the properties from the Excel sheet as well. And if the properties is saved elsewhere in any other kind of model file, so we can actually import those properties from that file as well. So suppose I want to import the properties from some other model file. So I need to go to here, import, and then I can search for that file wherever I have saved it. So project, so suppose, okay, I've selected the folder, and these are the basically the properties assigned in that model file. So I can just uh, transfer it to this model file as well. So I can click on OK. So then actually these properties will be automatically imported from that model file. I do not need to assign separately here. So these are the rock properties I am considering, and these are the nonlinear properties, the intact rock mass parameter, GSI disturbance factor. Based on that, these constants are automatically getting calculated, and these are the further two inputs regarding the uniaxial compressive strength and the latency angle. Apart from that, I have considered the shotcrete and the maybe some kind of material for the rock bolts. So here I have further created two properties for the shotcrete. First is the for the shotcrete. So as soon as we excavate and provided the lining, so the shotcrete may be having some lesser stiffness, but then it can get harder over time, and then the properties may improve. So to just simulate that, we can create these kind of two properties where this elastic modulus will be varying, so a bit more value for the hard shotcrete. So we are considering the elastic model for these shotcretes and the steel material. So similarly for rock bolt, I can assign the properties like this. Now, as I completed this step, so the next step will be to go to the property and assign the type of like elements I'm going to consider. So as it is a like 3D problem, so I'm going to assign my rock as a 3D type of material. So rock, I can click on apply. Apart from that, the lining will be a kind of like shell elements. So here we are modeling the lining as shell elements. So it will be like a 2D type of elements. I need to go to shell, and first I will create for the soft shotcrete one. So I can choose the thickness of the lining, and I can click on then OK. And similarly, I can create for hard shotcrete. Now for rock bolts. So rock bolts will be like this axial members. So it will be like 1D elements. So here the I need to assign the like behavior, the compressive and tensile behavior. So if I want to assign the compressive behavior according to the constitutive model, like the elastic model I have selected in this case. So I can choose this, and I can choose that material type for my rock bolt, which I assigned in this material option. And then we can like put some limit for the allowable tension for the rock bolt. Apart from that, we can enter the diameter of the rock bolts choosing this solid round section. Then this cross-sectional area will be automatically calculated based on our input of this diameter. So then I can click on OK. So in this way, I have done these two steps. Now actually every other things will be done by this tunneling wizard. So I will now directly move to the tunneling wizard here. This is static slope analysis step. We need to go to this tunnel modeling option. And here we need to start by defining the geometry. So suppose it's I can choose between circular 3 center circle, 5 center circle. So I'm going with this. This will be the material for the surrounding rock, which I created here using these steps. And then if I want to model twin tunnel, so I need to select 2. And if I want to see the geometry based on my inputs, so I can click on this. And then if I want to include invert as well, so I can include these invert. I can adjust these parameters as well as per my requirement. And now I need to choose the method for my face excavation of the face. So either this is for the full cut method. If I want to like adopt any specific sequence, so I can go to others. So here we have some standard sequence like the bench cut, ring cut, 1, 2, CD cut. So these kind of things. So suppose I'm going with this. This is the total height. So suppose I'm going with 8 meter. I will update this. Then it will be visible here. And so this is regarding the geometry. Now next thing I need to do the go to the shortcut and rock bolts. Here, if I want to consider, because I have like assigned the properties when the shortcut is soft and then when the shortcut is hard. So I need to mention those two properties here. So first one is the hard, means the like this one is the hard, and then if I'm considering the soft shortcut as well in the analysis, so I need to check this option and go with this property. Then for the rock bolts, I need to choose the number of rock bolts, the length of rock bolts, and the spacing between the rock bolts. So suppose I'm going with 12 numbers, 6, and so we can also consider the staggered disposition, means the sequence of the rock bolts, installation of rock bolts along the tunnel axis. So suppose now at this point it is the arrangement is like this. So it means like the 12 rock bolts are visible. So if I click on this staggered disposition, and +1 means in the next sequence in the next excavation, then it will be like 13 rock bolts. So arrangements will be like 12, 13, 12, 13, 12, 13. And in -1, it means like 12, 11, 12, 11, like that along the tunnel axis. So now the next thing is regarding the tunnel excavation. So we need to choose whether we want to simulate the excavation from one direction or from both the directions. So suppose of now I'm going with one direction, and now we need to select, because it's a twin tunnel, so which tunnel is getting excavated first in the analysis. So suppose I go with the left tunnel, so the tunnel on the left side, so then I need to select this. And then we need to select it after the first excavation. So after which stage the support systems will be getting installed. So if I want to in one stage I will be excavating, and then in the other stage means just the next stage I am installing the support system. So I need to go with one. So suppose if after two stages I need want to install, then I need to enter the values 2 here. And similarly with the second tunnel. And here for the second excavation tunnel, means the right side tunnel, I need to mention that after what excavation, what number of excavation stages of the left tunnel, the right tunnel will be started getting excavated. So if I want to excavate I'd want to do the first stage of excavation for the left tunnel, and in the other stage I want to start the excavation of the second tunnel. Then I need to enter it one. If I want to do it after the two stages, then I need to enter two. So accordingly, I can enter the value here. And here I need to mention the advancement of my tunnel, how the excavation of the tunnel will be proceeded. So suppose my first excavation is of 1 meter, second excavation is of 1.5 meter, and the other excavation is of like then 2 meters each, up to 20 meter. So I need to enter like this 20 at 2. So then this kind of excavation sequence will be modeled by the software, and these are the spacing between the rock bolts. So as you can see here, if we want to change it, so we have this user, then we can modify the spacing between any of the rock bolts. So suppose I do one here, so this spacing becomes one between these two rock bolts. So in this way I can adjust the spacing as well. So once I define the excavation sequence, I will move towards the meshing. And here I need to enter the extent of this my problem domain. So first I will be entering the depth. What should be the depth? So suppose the depth is 75 meters. And what will be the extent of this extent at the bottom of the invert, like the lower boundary. So uh, I can, like, it will be multiple of this depth. So suppose the means it will be a multiple of the diameter of the tunnel adopted. So suppose 3 times the diameter, 4 times the diameter, and this is the center to center spacing between the two tunnels. So like 2.5 of the diameter. So I can adjust it also. Suppose I am going with this combination. I may increase the center to center distance. And if you so there may be a like overburden. So either I can consider that overburden by using the surcharge load. I can put any value, or else I can actually model this exact kind of terrain over the my this domain by like inputting the elevation point data. So just to briefly tell you regarding this, if I okay, I will show you that once we will complete this process. So now here we need to select the mesh size. So this is regarding the mesh size along this tunnel periphery, and so we can suppose I am considering it 1.5 meter. And then the mesh size in the other portions, so we can customize based on this input. So then these will be the multiples of this input. So the now the surface, at the top of the surface, what will be the mesh sizes? So it is at the far, so I can choose a coarser elements. So likewise in the intermediate, means in between these two tunnels, suppose I want to go with the same size as this 1.5 meters. So I will enter one into tunnel mesh. Then for the other regions, I may go with some other size. So then actually I can, after this, I can click on OK here. And once I click on OK, so this tunnel model will be created automatically based on my inputs, which I have just discussed. So now actually this is the this is the entire tunnel domain, and the overburden pressure has been applied as per my input. And if we want to see the other mesh set, so basically the geometry created automatically, the mesh set got assigned uh, automatically here. So I can see this is for the ground, this is for the first tunnel, this is for the second tunnel, and this is the shotcrete lining, and this is the shotcrete lining for my second tunnel. And these are the sequence of rock bolts as per my input of the number of rock bolts, length of rock bolts, and the staggered disposition, which I mentioned there. I choose +1. So that's why we can see that kind of different arrangement along the tunnel lining. So so all these things are automatically created by the wizard. The next one is the assignment of boundary conditions. So the suitable boundary conditions have also been assigned, which is the like outer boundary conditions, and these are the boundary conditions for some conditions for converting the soft shotcrete property to the hard shotcrete property as the tunnel excavation progresses. So all these things have been created automatically by the software. The self weight of this entire assembly has also been defined by the software based on the input of my material property, the unit weights of the materials, those things. So now after that, because the tunneling excavation is in terms of like multiple stages of excavation and subsequent installation of support system. So there may be many stages. So the construction stages have also been defined automatically by the software. I can edit it if I want to make some change, but this much of construction stages have been automatically defined, which reduces my manual effort. So this is the first one, this is the second. So if I hide this, you can see this kind of excavation sequence. So if I go to this activate, then we will be seeing the excavation and support installation of the tunnel. So we can see it here as well. So this entire sequence has been like automatically defined by the software based on our inputs. Now so I just need to start the analysis here. Analysis case has also been defined automatically. Here's analysis controls and everything. In output control, if I want the strains also, I just need to tick on strains. I can click on OK and I can start the analysis. So if I have not saved the file, so it will tell me to save the file first. So uh, now I have saved the file. So then analysis will be started here. So generally this kind of geometry will maybe taking 5 to 10 minutes for analyze the complete analysis. So I have like analyzed this geometry already. So I will directly go to these results. So generally, when we run the analysis, so the each stages are getting executed, it will show us these kind of message in the output window. So as I have done this analysis, so I will directly go to the results. So in results, actually, the software will report the results in all the construction stages created. So suppose I'm going to the final stage of excavation. I can see the different displacement components here. So I can go here and if I want to see the values of the displacements along this tunnel periphery, so I can go to the probe command and I can take on click on any random node here and I will get the values corresponding to that. So I will get these values for any kind of like variable. This the vertical displacements, maybe this vertical displacements, horizontal displacements, and so further, if I want to see the displacement profile at any of the like stage along this tunnel excavation, so I can use this clipping plane option and I have to define the clipping plane. So suppose I want to cut along this plane along the tunnel axis. So this is the y-axis. So I will go towards this and then I can add this plane and I can move this also. So at any point where I want to see, I can add that plane. So once I add this plane, so then I can see the results at that particular section and I can see the deform profile as well. So apart from that, if on this plane also I want to get the results as per my selected nodes, so I can go to this option 3D 2D wizard and I can select the points on this plane also to see the displacements and other things. So apart from that, if I am interested to see the like mobilization of like the strengths of my rock bolts and lining, so I can just hide this mesh. So suppose for this tunnel I want to see and the forces over the like rock bolts, axial forces. So I can get this kind of distribution and the maximum and minimum like axial forces. And similarly, I can see the bending moment and shear force distribution along the lining. And apart from that, if I want to see the distribution of these forces at any section. I can go with this cutting diagram tool. I can choose cutting plane. I can see the distribution along the lining for the selected variables like the shear force and the bending moments. So, and I can get the values here in diagram. I can go to show table and I can get these values here as well. So I can copy it if I want to export it in Excel. So now apart from this, the last thing is the support capacity plots. So suppose I want to plot the support capacity plots for the lining. So I can go to this option, tunnel lining plots. Before that, I just need to extract some results like the bending moment, shear force, the axial force along any section of the lining. So suppose if I want to extract it for the final stage, and these are the shell element forces, all the components, and I can select the nodes at that section. So I'll go to the top view. Suppose I'm selecting this section. So I selected all the nodes, and then I can just go to the table. So I will get these values along that section. So then actually I can go to this tunnel lining plots. I can click on OK, and I need to enter. So in case of like a composite section like lattice girder where there may be both shotcrete and steel, so we may need to enter the properties for both. But suppose I am going now with the lining having a shotcrete, so I don't need to enter the properties for steel. And I just need to enter the properties of the shotcrete. So the elastic modulus which I entered for the shotcrete, and the compressive strength means according to the grade of concrete M20, M30, and the tensile strength as per the like if I want to go with the IS code formula 7 under root FCK. So then the Poisson ratio, and this is the shotcrete thickness I entered as 0.2 meter. This is the shotcrete area 0.2 into uh, per meter width if I am going like that. So moment of inertia is per like BD cube by 12. So and the radius of tunnel, and these are the factor of safety envelopes I want. Suppose I want for more 2 3, then I can enter the values here. Then I need to enter the results which I get from the analysis. So first one is the bending moment. So then is the forces, axial forces. You can copy this and paste it here. And last one is the shear forces. So then I can just click on get redistributed force, and then I can click on this view curves to generate the curves here. So these are the curves. So now for according to the input factor of safety and L1 1.52. So as you can see, the all the points along my lining for the chosen section are lying within this factor of safety envelope of 2. It means they are having we are having factor of safety more than 2 on these locations. And this is in case of moment, and this is for the shear force. So in this way, we can see whether the lining provided is appropriate or not, and if these points are going outside, so we can redesign the lining accordingly. So this was all regarding the problem demonstration. Now, actually, if you are having any doubt in this regard, or any other software capabilities, so you can write down in the chat box. So I will be responding to those questions. There are some questions in the chat box already. So license, yes, I think the its license details are provided in the mail which you might have received. Generally, you may be getting a license for 15 days. Yeah, so another significant question, what if we having different ground profiles condition along the proposed section? Okay, so if that kind of problem is there, so we can actually, we are having some manual approach for modeling as well. So suppose you can you can select the tunnel section from here as well. There's an option for the creation of geometry. It is like a kind of the complete automation is not there. This is a kind of manual method, but there are some options regarding this automatic creation. So one is this geometry. So here, similar to the tunnel wizard, we can create this kind of geometry, maybe the length of rock bolts and the spacing between the rock bolts. Then we want to create the domain, and we can create as per our requirement. So this is my 2D geometry. I can extrude it to a 3D geometry. Then whatever length, like suppose for some extent it is maybe a different rock and properties, and for some other extent maybe different rock properties. So in that case, we can decide this, and suppose then this part, and then further I can create another part choosing this. So like this, I can create a 3D geometry, and similar thing I can do with my tunnel portion. I can extrude it. Uh, and then actually, I just need to mesh the domain. as per my like material properties. I need to assign the suitable material properties to meshing in those sections. And then I have some for the like assignment of the construction stages. I have some automation in the manual approach as well. So here we can go for the stage wizard. So we have a stage wizard in case we the tunneling is too much complicated, or there may be some tunnel connections in between the tunnel, or there may be like more than two tunnels. So in those kind of cases. So here we just need to define the pattern of the activation and deactivation of the excavation and support system. So suppose if I can show you one model. So so as you can see in this model, maybe a connection is also created. So in a stage set, actually whatever mesh sets we created, like the excavation portions of the tunnel and the installation, so we need to just add it here. And so and then we need to assign it whether it is going to get added or removed. So suppose excavation volume is getting removed in each stage, so we need to select R for that. And in case of any support system that needs to be activated, so then I need to add A. So suppose tunnel rock bolts will be activated, and here I need to just mention the starting stages, at what stage the X like activation of the rock bolts will be getting started, and what will be the intervals for the installation. So then accordingly, the multiple number of construction stages will be automatically created by the software, as you can see it here. So here in this way also you will get some automation regarding the like development of the construction stages and the geometry creation. You just need to put some effort in the uh, extrusion conversion from 2D to 3D geometry, or and the meshing part. So other things like will be automatically done. So apart from that, there are many questions. So recording will be shared, and to write it. Yeah, we can analyze the stresses and the displacements checks. We can actually get the values of the displacement or stresses from here. Then you need to analyze whether they are like safe or not. So if you are following any guidelines. So according to that, you need to analyze. And the mobilization of strength of the support system that I already mentioned, that we can plot the tunnel support capacity plots, and we can see the actual force mobilization over rock bolts. Either it is exceeding the strength of the rock bolt or not, so that we can analyze directly from here. How to calculate surcharge? Surcharge above the tunnel you can calculate based on the that total height, and then multiplying it with the unit weight. So accordingly, you can put a uniform surcharge, as I showed in the this tunnel wizard as well. And but if your like profile is varying, so then you can provide the kind of elevation data in the software. I think I forgot to mm, briefly tell that point. I'll just mention here. So this we can do it here. So suppose, so we can actually capture this kind of like actual terrain surface. So in this case, we do not need to put the overburden pressure separately. So we can actually create that geometry using this elevation data. So in the both the extent in the X and the Y extent, then this actual terrain or strata surface will be automatically created. Otherwise, if we are not using tunnel wizard, we can actually create the this kind of terrain geometry through this uh, terrain geometry maker option, which we have here, where we need to actually import the contour map here. So once we enter the once we input the contour map, then we can create that kind of actual surface uh, over this, and then this overburden will be automatically taken care into account. Some I'm looking for some more questions. There are many questions here. Can it provide allowable settlement? So allowable settlement, actually we have to refer any guideline. It can give you, it's like basically the FEM analysis can give you based on the overburden pressure and the properties of the rock, the method of excavation of the tunnel. It can give you what settlements are expected to come. and whether these are allowable or not. For that, you may have to refer some guidelines for the field monitoring data, as I showed the case studies where they were comparing the software results from the field monitoring data. So in that way the results can also be validated, and whether that much of, even from the field monitoring data, if those settlements are allowable or not. So the then we need to follow some like established guideline to confirm that. Okay, so someone has asked, how can GTS NX be effectively applied for numerical modeling of urban metro NATM tunnel in complex geological environment? Proposed tunnel 10-meter in diameter, passes beneath old and highly vulnerable surface structures with a shallow groundwater table. The subsurface condition comprise 2 to 5 meter of soil. Yeah, multi-layered soil you can provide it. Then if the like jaw this your topography or the terrain is to means like complex with multiple layers of soils, and then we can just, as I showed you this, we can use these to create a 3D geometry. We can separate this geometry into different parts, as I divided in along the axis, so we can do similar thing along the depth as well. And then we can assign the different properties to different sections. And we can do, as I mentioned initially, we can also perform the seepage analysis here. So we have this in case if we have groundwater, and we need to see the effect of groundwater over the tunnel linings, all those things. So we can go for the stress seepage. So these are different analysis type. Coupled stress seepage analysis we can go for. And here actually we have these different stages. So steady state for the initial water table, and if we want to see the evolution, means as my tunnel gets excavated, so what will be the drawdown of the water table, and what will be the phreatic surface from the far end to the tunnel face. So how it will look like over a certain period of time. So I can go with the transient analysis. So these are the possibilities or considering the seepage in tunnel models. So yes, with the modeling with very varying soil or rock layers, as well as the water table condition, seepage analysis uh, can be done here. And for heterogeneous or discontinuous rock masses, can GTSN explicitly model discontinuity? So yeah, we can actually define the kind of discontinuities in terms of interface. So we can provide interface. So we have this option. So we can actually provide this kind of plane interface along any section. So suppose the joint is like this, somewhere like this. So we can divide this geometry accordingly, and then along this plane we can assign the interface, and we can like either give some reduction factor, or we can manually also assign the properties for the interface based on these contact models. And or does it represent their influence through equivalent continuum rock mass property? Yeah, this is also possible, because like as we are using the this type of models also, the Hook and Brown, generalized Hook and Brown model, as well as we have some other models also for rock, generalized Hook and Brown. And if I want to go to this, I will go to this orthotropic section. Here we have this. transversely isotropic model, which we can use, where we can actually give some details of the joint set regarding the dip angle, dip direction, declination, and the other properties. And we can also go with the jointed rock mass model, where we can give the details of maximum 3 joint sets, and we can give these properties, and accordingly the software will calculate the overall equivalent continuum rock mass properties. So this is also a possibility. Which type of settlement? Settlements actually we need to um, specifically we need to assess the settlements along the tunnel lining, uh, and there may be like resultant displacements or the vertical as well as horizontal settlements we can see, and we can see the settlements at specific like portions, especially the roof section of the roof portion of the tunnels, and then we can assess whether those settlements are significant or not. So there may be some few more questions. I'm looking for it. Uh, So someone asked whether this is possible in FENX or not. So they have the license of FENX. So you can do the same thing in FENX as well. This is the FENX. So here you can find in geotechnical analysis this option, tunnel modeling, and the if the it is like complex geometry, then the process you can use these tools. So the similar tools are there. So it can be done. So how can MIDAS software be integrated with wind tunnel test data to calibrate and validate the structural response of tall buildings or bridge models under dynamic wind loading? Okay, so that generally I will be confirming this with any of our structural engineer, because they do it in this structural MIDAS structural software as well, and if we are having some kind of a tutorial or kind of a model, maybe, or a kind of a process, so I will be sharing with you. Okay, I think how seismic analysis. Oh, last question is there. Uh, some more questions have come up. What methods? Okay, so regarding the doubts regarding the wind tunnels, so that I will just confirm it with our structural engineers as well, and I will be responding you. So Dr. Puneet Jain has asked this questions specifically, and apart from that, the last one is that how seismic analysis can be done. Uh, in heterogeneous soil mass. Okay, so the last question. So we have actually this dynamic analysis tab here. So as you can see, as I in the presentation also I mentioned that dynamic analysis in case of like seismic condition and the dynamic maybe blast loading condition can be done. So here we have this. So this is the dynamic load, blast dynamic load. If we want to generate, we have these. So we can actually simulate controlled blasting. So based on these approaches we have in the literature, and we need to enter these parameters like the blasting velocity, explosive density, charge diameter, borehole diameter, and these things. And then accordingly we can generate the dynamic load, and we can apply the dynamic load to the analysis. So suppose And as I was telling, just 1 minute, I will. Okay, so I will close some of the windows. So, okay, so suppose this was a simple model for blasting. So here actually once we do that kind of load generation from the this dynamic data load generation, so then we can apply it in terms of the dynamic loads. So as you can see here, so at the face of the excavation, I can apply the dynamic load. So this is the blast load generated from the blast loading wizard. So this is the blast load. So I can assign this to the my tunnel over this face, and I can simulate the blasting effect. So I have to see with the like tunnel excavation what is going to be the influence zone after the blasting. So So similarly for the earthquake loading, we can go to this seismic data generator or the ground acceleration. So we can do actually different kinds of analysis, either assigning the dynamic load or over a surface, or dynamic nodal load, the ground surface acceleration response spectrum as per the IES 1893. So suppose this is the ground acceleration. I am going to input the earthquake data. So here we can create that as a time function. So here we can, according to the earthquake data, we can input the values here. Otherwise, we have data of earthquakes as well, different earthquakes. So we can choose from here as well. So then this, we can assign it. And here we can select that and create a dynamic load set, and it will be visible here. And then actually we can assign it into the R model. And apart from just the dynamic load generation, we have some different like viscous boundary conditions to capture the like effect of the this kind radiation damping. So we need to assign that kind of boundary conditions in any dynamic analysis. So with this actually we can simulate these kind of seismic analysis in the software. I think all the questions are done. So then we can end this session here. So thanks for joining, and thanks for such like detailed questions. So then some few leftover questions, then I will pertaining to the structural analysis, I will be responding to you over email. So recording and the recording you will be getting after this session. You will get the recordings. So thanks for joining the session.